Welcome back to Data Explained. Today, Episode 6, Message Queues, the quiet backbone that lets services hand off work instead of grinding to a halt waiting on each other. The core idea is almost stubbornly simple. Do the work later, not now. Over the next few minutes, we'll unpack why that small shift is what makes modern systems actually scale. So let's start with the pain. Picture a user uploading a video, and then your app tries to transcode it, generate thumbnails, and fire off emails, all in the same request. They're stuck watching a spinner for minutes. One slow step blocks everything else. And if anything crashes halfway, the work is just gone. But here's the thing. What if your app could simply jot down a note that says, "Process this video," reply instantly, and let the heavy lifting happen in the background? That note, that's the message queue. So let's pin that down in one sentence. A message queue is just a buffer that sits between two services. One side drops tasks in, the other picks them up and processes them on its own time. That's really all it is. An ordered holding area for work, where the sender and receiver are decoupled and everything happens asynchronously. Nobody's waiting on anybody. To make that concrete, picture a busy restaurant. The waiter doesn't stand at the stove waiting for each dish. They clip the order to the kitchen's ticket rail and head off to serve other tables. The cooks pull tickets down at their own pace and get to work. That rail is doing exactly what a message queue does. The waiter is your producer, the rail is the queue. Each clipped order is a message, and the cooks are your consumers quietly working through the backlog. Strip that restaurant down to its essentials, and you get this picture. A producer on one side dropping messages in, a queue holding them in order, and a consumer on the other side picking them up one by one. Most queues work first in, first out. The oldest message gets handled next, just like tickets on that rail. And the key thing is the independence. The producer never waits for the consumer to finish. It drops the message and moves on. That independence is the real prize here, and it has a name: decoupling. In a tightly coupled setup, your app calls the worker directly. So if the worker is down or slow, your app goes down or hangs right along with it. Drop a queue in between, and suddenly the app just leaves a message and moves on. The worker can crash, restart, or scale up later, and nothing's lost. The messages just wait. So once you've decoupled things, what do you actually get out of it? 4 big wins. Responsiveness. Your app replies to the user right away while the real work happens in the background. Resilience. If a worker crashes mid-job, the message is still sitting in the queue, ready to be retried. Scalability. When the backlog grows, you just add more consumers to chew through it. And smoothing. When traffic suddenly spikes, the queue acts as a shock absorber instead of letting the load hammer your workers directly. Let's zoom in on that last one because it's one of the most underrated benefits. Real traffic is never smooth. A flash sale, a viral post, a nightly batch job all send work crashing in at once. Without a queue, those spikes hit your workers directly and something breaks. With one, the surge just piles up safely in the queue and your workers drain it at their own steady pace. Bursty in, sustainable out. Now, once messages are flowing through a queue, there's a fair question. What happens if something goes wrong mid-delivery? That's where guarantees come in. At most, once is fast, but accepts the occasional lost message. Fine for things like metrics. At least once is the common default. Nothing gets lost, but the same message might land twice. Exactly once sounds perfect, but it's genuinely hard and expensive to pull off. The practical takeaway. Since you'll usually live with at least once, design your consumers to be idempotent. Processing the same message twice shouldn't break anything. With delivery guarantees in mind, let's zoom out and look at 2 very different patterns for moving messages around. A work queue hands each message to exactly one consumer. Workers share the load, and a task gets done once. Think RabbitMQ. Pub.sysub flips that idea. Each message is broadcast, and every subscriber gets its own copy. Think Kafka topics. So the real question isn't which is better, but whether you want one worker to act or many services to react. So where does all this actually show up in real systems? Background jobs are the classic case: video encoding, image resizing, generating reports. Anything heavy you don't want blocking a web request. Notifications are pure fire and forget. Drop the email or push onto a queue and move on. Order processing leans on queues to split checkout, fulfillment, and charging into safe steps. And at the largest scale, queues become the wiring between microservices, letting them react to each other's events instead of calling directly. It's worth zooming out for a second and seeing how queues sit alongside the other tools in this series. Indexes help you find data fast. Caching saves you from repeating the same reads. Sharding and replicas spread the data and the reads across machines. Queues are the odd one out. They don't speed up reads at all. They spread and defer the actual work. Same goal though: stay fast under load, just by attacking a different pressure point. Before we go deeper, let's clear up a few myths that trip people up. A queue doesn't make the work instant. It makes the response instant. The actual job still takes whatever it takes. Just out of sight, messages usually arrive at least once, not exactly once, so duplicates will show up and your consumers need to handle them safely. And no, it's not just a database table. Real brokers give you ordering, retries, acknowledgements, and scale you really don't want to rebuild yourself. Speaking of consumers handling things safely, what happens when one of them just can't process a message? Here's the nice part: the message isn't lost. It goes back on the queue and gets retried, usually with a small back-off, so you're not hammering a service that's already struggling. Most transient hiccups heal themselves this way. But if a message keeps failing every single time, you don't want it blocking everything behind it. So the broker shunts it off to a dead leader queue where it sits quietly until you come investigate. So which tools actually do all this in the real world? You'll run into RabbitMQ a lot, the classic flexible broker, and Kafka when teams need serious event streaming throughput. Redis Streams gives you lightweight queues if Redis is already in your stack. And on the managed side, AWS SQS, Google Pub Sub, and NATS each cover the same core promise: hand off the work now, process it later, just with different trade-offs in scale, delivery guarantees, and how much ops you want to own. Let's pull the key ideas back together. A queue is really just a buffer sitting between services. The producer drops work in, the consumer picks it up, and neither has to wait on the other. That's what lets you reply to a user instantly while the heavy lifting happens in the background. Just remember, most systems deliver at least once, so design your consumers to be idempotent. And the shape matters too. A queue feeds one worker, pub sub fans out to many. So when should you actually reach for a queue? It's a great fit when work is slow and can wait, when traffic comes in unpredictable bursts, when you're wiring microservices together, or when losing a task simply isn't an option. But it's overkill for a quick request response when you need the answer right now, for tiny apps with no background work, or when strict ordering is non-negotiable and can't be relaxed. If this sparked your curiosity, the Data Explained series goes further into the foundations around it: SQL versus NoSQL, indexes, ACID, sharding and caching, and of course, more on message queues themselves. And one quick reminder before you wire anything up: queues carry sensitive work between services, so authentication, encryption, and access control deserve the same care you'd give any data store. You'll find it all at dargslan.com/courses. Before we wrap up, I'd love to hear from you. What's running in the background of your projects right now? Is it RabbitMQ, Kafka, SQS, something else entirely? Or are you still at the stage where everything happens inline? Drop a comment and tell me which broker you reach for and why. These little details are how we all learn from each other. And that's message queues, the quiet layer that lets your services say, "I'll handle it later," instead of grinding to a halt. If this one finally made the concept click, hit subscribe and stick around for the rest of the Data Explained series, where we keep unpacking the backend ideas everyone uses but rarely explains. Thanks for watching, and I'll catch you in the next one.